Welcome to Chapter 6, more about triangles. This lesson is about the Pythagorean Theorem. So how do we use the Pythagorean Theorem to find the missing side of a right triangle? Well, the Pythagorean Theorem states that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So if we label our triangle with A, B, and C, C being the hypotenuse, then the sum of the squares of the legs, so sum means to add, the squares of the legs, so A and B will be the letters we use to represent the legs, so A squared plus B squared is the sum of the squares of the legs, is equal to, so there's the equal to, the square of the hypotenuse. So we take that hypotenuse, which will be marked with a C, we take that hypotenuse and square that, and this is the Pythagorean Theorem. A squared plus B squared equals C squared. C will always be the hypotenuse, and since A and B are the legs and they're just being squared and added together, it does not matter which one is A or which one is B. We simply need to make sure that C is the hypotenuse, which is opposite of the right angle. So in these examples, we're going to find the length of the missing side. Exact and approximate we will deal with as that issue arises, and that's really just because we're going to be square rooting. So there's an exact and an approximate, and again, we will deal with that as we go. What's important for you to recognize when you are given a right triangle is which side is the hypotenuse. So the hypotenuse is always the side opposite of that right angle, and so this case, we do not have that value, so we are missing C. It does not matter if the 16 or the 12 is A or B. We do want to make sure that we are using the Pythagorean Theorem, which states that A squared plus B squared equals C squared. So 16 squared plus 12 squared equals C squared. And again, it does not matter if you wrote down 12 squared plus 16 squared or 16 squared plus 12 squared. Either way, we'll get the same answer. So using your calculator, you would square 16 to get 256, square 12 to get 144. You're adding those together to get 400, which is C squared. And then this is the point where we need to make sure we're remembering how to solve an equation. We're not done here. I don't want to know what C squared is. I want to know what C is. So we need to undo this squaring. And remember that in order to undo a square, we square root. So we need to square root both sides. And you guys are welcome to use your calculator for this part, the square root of 400. And I would always start with the calculator because if it's a nice whole number, like it is in this case, then there's nothing else for you to do. C equals 20. There's no exact or approximate, like this is just the answer. The issue arises when we plug in this square root and get a decimal. That's when we're gonna have to deal with exact or approximate. But in this case, it's just a nice perfect square, so C equals 20. For this problem, it looks like we're missing our C value again because it is across from the hypotenuse. So using the Pythagorean Theorem, A squared plus B squared equals C squared. Again, it does not matter if you use the 2 or the 3 for A or B because they just get squared and added together anyway. So this is 4 plus 9 equals C squared. Well, that's 13 equals C squared. And again, I know it may have been a little while since we've done this sort of solving, but it's going to happen over and over again that we have to square root in order to find the value when we're solving the Pythagorean Theorem. So in this case, if we type in the square root of 13 in our calculator, it's going to give us a long, ugly decimal. So what I want you to understand is technically C equals the square root of 13. This is called an exact answer because there is no rounding. There's nothing to simplify. This 13 does not simplify in any way, and there will be a problem later where you will see what I mean by simplifying. But the only thing we can do with this is to get a decimal. And the deal with the decimal is that so many students like to think that the decimal is exact, but the decimal is actually the approximate because since it's not a perfect square, it's an irrational number, which means it goes on forever and ever and ever and ever. So we actually have to round to get that 3.61 because the actual number is 3.60555127555 and so on. It doesn't stop because it's not a perfect square. So we have to round. So that actually makes the decimal be the approximate answer because of the rounding. So in this case, the square root of 13 is the exact answer and 3.61 is the approximate answer. In this problem, again, it's always important to start by identifying the hypotenuse. In this case, C is 20, so that is not the piece we are missing. Instead, we are actually missing a leg. It does not matter if you label that with an A or a B. So A squared plus B squared equals C squared. Since I've labeled my missing side with an A, I'm gonna leave that as A squared. That means that 16.2 is my B, so that needs to be squared, and 20 has to be the C, and that there's no choice with that because that's the side that is opposite the right angle. So we're gonna go ahead and start simplifying this and solving for A. So square rooting 16.2 and 20, and then subtracting the 262.44 from both sides. I get that A squared equals 137.56. So again, my last step will be to square root both sides of that to find out what just A equals and not A squared. Now, since I am starting with a decimal underneath my radical, underneath the square root, there is no choice but to get a rounded decimal for my answer. So in this case, there's actually no choice other than an approximate answer for this. So I urge you guys to plug it into your calculator so you can compare the decimal answers that you see on your calculator with the rounded answers that I am providing. So A is approximately 11.73. My calculator is giving me 11.7285975.291 and so on. So I had to round that 3, or round to make it a 3. So technically this is an approximate answer and there is no exact answer. It's not that there's no exact answer. The exact answer would be that A equals the square root of 137.56, but we don't leave numbers in this form. We don't leave square roots of decimals. It's just not common. So we don't leave it like that. This is not a nice number. We would always just find the decimal and round in this case. Last one, finding C as 7.1. That's the side that is opposite the right angle, so it is the hypotenuse. It does not matter how you label the other side. I'm gonna make it B simply because it's like second, like I see in A squared plus B squared equals C squared. I see the 5 first. So I'm writing 5 squared plus B squared equals 7.1 squared. And we're just gonna go through and simplify this. And then we start to solve. And we get B squared equals 25.41. And then again, just like in every other problem, we will have to square root that to find the actual value for B, which in this case, we will have to round. So I guess I'm gonna go ahead and make those approximate symbols, and you won't be marked off points for leaving it an equal sign or approximate. I just want you to realize that technically when we have to round, it's an approximate value and not an exact value. Let's take a look at some real world examples. This one says that a rectangular bookshelf needs a diagonal support brace. Which piece of wood should be used? Now in this case, I'm pretty sure I was missing something with what's on the, I didn't put something in your notes. So when it's asked you about which piece of wood should we use, we're just gonna go ahead and answer like how long of a piece we need because I didn't give you any choices out of which piece of wood. So let's just go ahead and solve for the diagonal support brace that we would need for this rectangular bookshelf. So since it is a diagonal support brace that we need, we're going to use the Pythagorean theorem to find the length of the piece of wood. So C is going to be the part that we are missing because that is the diagonal. It is opposite the right angle that is created with the bookshelf. And so again, it doesn't matter, 30 squared plus 4 squared or 40 squared or 40 squared plus 30 squared, doesn't matter which one you put into A or B. We simplify that to get 900 plus 1600, which is 2500. That does need to be square rooted, in which case you get 50. So the piece of wood would need to be 50 inches long. This one says televisions are measured by the lengths of their diagonals. Find the measure of this TV. And I want you to realize this is a true statement. When you get a 64-inch television, that's not referencing the height or the length. It's referencing the length of this diagonal here. So though this one may be 21 inches tall and 28 inches wide, the question is, what size TV did this actually get, and that we actually use to reference the size of a TV is the diagonal. So since it is the diagonal and opposite of the right angle created by the television, we are missing the value for the hypotenuse, or C. So we plug in the 28 and the 21 in for the legs, we square them and add them together, and we get 1,225. We have to square root that in order to find the actual value for C, which in this case is a nice perfect 35. So this television that's 28 inches long and 21 inches high would actually be called a 35-inch TV. Final real-world example here is referencing a 20-foot ladder that is leaning up against a house. If the base of the ladder is 5 feet away from the wall, how high up does the ladder reach? Now you can see here that there is no image, and it might be beneficial for you to draw a really quick little house with a ladder coming off of it and labeling your diagram with the 5 feet away from the wall, and that it's a 20-foot ladder. Let's take a look at what mine's gonna look like. All right, so here's my lovely little house. Got my 2 stories here because I just felt like drawing 2 windows, my landscaping at the side of the house. And then here's my 20-foot ladder. It is 5 feet away from the base of the wall. The wall itself is the piece that I am missing. It says how high up does the ladder reach? So we are missing this A value here. C is my 20 feet because that is the side that is opposite the right angle that is created with the house and the wall. So we're going to use our Pythagorean theorem. The 20 goes in the location for the C, for the hypotenuse. Plugging in the 5 in for B, I get a squared plus 25 equals 400. Subtracting, we need to square root 375 to find the actual value for A and how high the ladder reaches. And in this particular problem, I'm going to take a couple extra minutes and actually review how to simplify versus get the approximate answer for this square root. So we will take a look at the decimal, and actually let's go ahead and get the decimal answer first, and then we will look at a more exact answer. So changing this to the approximate symbol, because we are going to have to round this decimal to 19.36. So this is approximate because I am rounding the square root of 375 to 19.36. Let's take another look at actually simplifying this square root, a lesson that you learned in algebra. Taking a closer look at the square root of 375, please remember that an approximate answer would be 19.36 if we're rounding that decimal. I want to get an exact answer, which means to simplify this square root, and we just don't leave it as a square root of 375 because it can be simplified. It can be broken down into perfect squares. Well, if I take 375 and divide it by 25, and I chose to do 25 here because I see that it ends in a 75. And knowing my money and my quarters, I know that if I've got 75, I can divide it by 25. So it actually divides evenly, 25 and 15. So I'm doing a little factor tree here. 25, the reason why I'm doing that, besides the fact that it ends in that the problem ends in a 75, is because 25 is a perfect square. The square root of 25 is 5. The square root of 15, that's not a perfect square, so that's going to stay underneath the radical. Now, if you don't understand this, I really don't want you to stress about it. There were several different methods that get taught when simplifying square roots, so it is literally could be different for everyone watching this video right now. The point is that this value is exact because I did not have to round at all. It is exact and it is simplified. Okay, this 19.36 is approximate because it is a rounded decimal. Even the square root of 375 is more exact than this decimal. This just is not simplified. So those are just some things to consider whenever you are asked to find an exact and approximate answer. So this concludes the lesson on the Pythagorean theorem. So how do we use the Pythagorean theorem to find the missing side of a right triangle? It's important that we identify the leg and the hypotenuse, and then we just use a squared plus b squared equals c squared to solve for that missing side.